I don't smell your breath because you have on a mask. All right. What questions do we have off of this homework before we get started and/or distracted by stinky breath?
First of all, nobody got any sticky breath. And second,
What'd you
I
say?
got it all right. I don't have stinky breath. I had gum. It's burning my eye.
Sorry. Before we get distracted by eye burning due to stinky breath or gum to prevent stinky breath, something like that. Something like that. So, what questions do you have off of numbers 2 and 3 and 16 and 19 and Peyton? So help me. If you don't start showing your work, I'm going to start giving you zeros on homework.
Okay, I got them right.
No, you didn't. Negative 1.75 is not negative 2.
It's 25 off, 0.25 off.
And that's wrong in this case. You can have multiple solution paths, but when y is equal to negative 2, y is equal to negative 2. And you're making mistakes because you're using a calculator instead of showing your work. Now, can you use a calculator to help you do the calculations?
No.
Heck yeah.
Are you saying them?
Heck, you can even use Symbolab to check yourself.
Symbolab.
But what you cannot do is not show work and write down the wrong answer. See how that can be problematic? You know what that gets you on the rubric? Not just an F. Well, it's not, I don't know if it'll be an F overall, but it'll be a negative 1 on that rubric for sure. So, starting with 2 and 3, what questions do you all have about maybe how I approached it or where we made mistakes? The other thing, Peyton, is this, like, all kidding aside, you got that answer wrong for number 3. Do you have any clue where you went wrong?
No.
Do you know why you don't have
No,
any clue?
actually, yes, I do. It's because I did the positive. No, it's because I thought it was a negative one and not a positive one. So
That might explain it. But, so 1, pay attention to details. 2, if you'd written that out, you wouldn't have made that mistake. But my point more is, if you don't write it out, then you don't know where you may have made a mistake. Not for sure. So, Corel, did you get all these right?
No.
Do you need to ask any questions?
Yeah, I kept saying 3, 3, 3, 3, 3, 3, and you didn't say nothing.
3, 3, 3, 3.
I have a question though. Why does it say y equals negative 2?
Oh, that's from number 1.
Oh, okay.
That carried over from number 1. Well, Corel, how would we do number 2? If you don't have a question on number 2, you must have known something there.
Number 2? You plug in 558.
Okay. So guess what? What's the first thing I do for number 3?
Plug in.
Yeah.
Plug in negative 5 for x, right? So I literally just did that. 3 times negative 5 minus 8y is equal to 1. Next.
Negative 15. Minus 8y equals 1. Division.
Fine.
Division.
So when do we use division? Or when would you use division in an equation?
When you're trying to undo multiplication.
Do we need to undo multiplication with that 15, or that negative 15?
No. Subtract. Add 1. Subtract 1. Add 1.
So if we subtract 1, 1 minus 1 is 0. Negative 16 minus 8y. Did you get closer to finding out what just y is?
Yes. No.
Not really. I mean, you kind of, but like, remember, what I want to know is what this y is. So I need to get rid of the stuff around it. So, Kelsey, what did you say?
Oh, I said add 15.
Corel, what is negative 15 plus 15?
0.
Is that getting us closer? So 0 minus 8y is just, am I now closer to solving for y, getting y completely on its own? Now what would I use? By? Negative 8 divided by negative 8. So 1y, or y. 16 divided by negative 8.
Two. Negative two.
But I want to remind you, because I already mentioned this, if you're doing this at home, and as long as you know to plug in negative 5 for x, you get this equation. Negative 15 minus 8y equals 1. What can you use at home to help you solve that and make sure you understand what the solution is? Simbo Lab. If you go onto Schoology, right, there is a page dedicated to those extra resources you can use at home. So use Simbo Lab to check yourself. That would not be a bad idea. It's good practice. You need to also show your work, but those are things to think about. 16 and 19, any questions before we move on?
Uh, 16.
Okay, what about 16?
How did you get it?
Get what?
The boundary line.
Okay, so when I look at this inequality, I'm looking at a boundary line, so I'm not going to look at the actual inequality. For the boundary line itself, I'm going to look at y. If I'm just looking at the boundary line, it's y
Equals 3x.
equals.
Mine's 4.
Remember, that's the inequality I'm trying to graph, but I'm going to start with the boundary line. Tell me, what type of line is that, or what form of the line is that? Slope intercept, right? So what is this 3? Slope, so 3 to divided by 1, rise and run. What is this negative 4? The y-intercept. So 1, 2, 3, 4, y-intercept is negative 4. And a rise of 3 and a run to the right of 1. Rise up 1, 2, 3. Apparently I mislabeled a point. Should be there. And then 1, 2, 3 to the right 1. Sorry about missing that point. We'll fix that on the solutions. Now why is that a solid boundary line?
Because it's greater than, equal to.
It can be equal to, right? It's not a strict inequality, it can be equal to, what is that one, number 16? So that's 5.6, number 16?
Yeah.
Okay. And so I do want you to notice, do I even make mistakes?
Yes.
Is that okay?
Yeah.
What did I say I was going to do?
Fix it.
Fix it, right? It's okay to make mistakes, we just got to learn from them, grow from them, and get better. Okay? You good with that boundary line now, Peyton? You just have to recognize that slope intercept and use your slope and y-intercept. Remember, yesterday, I have my work up here showing x and y-intercepts, but didn't we show on number 19 that you could convert it to slope intercept? Same thing. And it'll give you the same boundary line. Okay. Oops, too far. So, what do you think we're going to do first today?
We're gonna read our objectives.
Go to sleep.
Oh, I know, it'd be nice to go to sleep, but it is not nap time, we're not at home, so we are learning math. Alright, but we are going to look at objectives, like we usually do. And then we're going to get back to 5.6, more or less. Desiree, would you like to start us off on the objectives?
Yeah.
Knock it out. So, Layla, let me ask you this, just in general. If we're going to graph a system of inequalities and identify the set of solutions, how do we do that? What does that mean?
Looking at the boundary line.
Okay, I would agree a boundary line is a huge part of it. We got to start by getting those boundary lines, but what else do we need? Is a boundary line all we need with an inequality?
No, boundary line, say a half plane.
I love that language, right? Notice the boundary line is going to cut the plane in half, and so we're going to shade a half plane, right? So is it enough to just stop at that boundary line? Nope, we got to
Shading.
what are we shading?
The half
Yeah, but why do we shade this half plane? Why didn't we shade what's above it? Solutions, the things that make the inequality
plane.
true. We all good with those ideas? Okay, but here's the thing, this is what we really introduced in the last task of 5.5. So how does that change when I have a system, right? Not just one inequality, what am I looking for if there's two or more inequalities? Do you remember, Layla? Remember, if one inequality, we're looking for just one shaded area for the solution. If we have two or more, you don't remember from 5.5? I'm going to ask you this question tomorrow, so listen in for anyone else to be able to explain it. Who can explain what we're looking for when we're looking for a system of inequalities? Kelsey? Well, I thought she was raising her hand, I was going to reward that, but she's like zigzagging with her hands, I don't know what that is.
What do you mean, what are you looking for?
For one single inequality, we're looking to shade the solutions, right? But what if we have a system of inequalities, what are we looking for?
Well, you need to shade the solutions for each constraint as well as the solutions for both constraints.
Well, so remember, we do shade each individual inequality, but we're looking for the overlapping shading, right? So we shade each of those inequalities, but we're only looking for the solutions for the system, so what makes both of the inequalities true at the same time, okay?
Yeah.
Cool. Shelby, can you read our second objective since I talked over you earlier? That was my bad.
I can write the algebraic representations for a system of inequalities based on the graphical representation.
So we've actually written algebraic representations for one inequality. We're just now going to look at two or more. And that's all that is. Corel, can you wrap us up on objectives? Never mind, Peyton, can you read it since Corel's acting wild? I'll get back to you tomorrow.
I can determine when a linear inequality includes the constraint on the boundary line, solid line, and when the inequality is strict, dashed line.
Okay, so when we have solutions are on the boundary line, it's solid, and when the inequality is strict, just less than or greater than, it is dashed. And I am sorry, Corel, but we have stuff to learn today.
So we can't stress in your class and get in trouble for stressing? Okay.
I'm making a point that you're wasting class time.
I had to stretch.
No, you didn't.
I really did.
No.
You
No.
can't stop when you're stressing, I know.
Well, that's why you gave up the chance to read the objectives. You want to read the objectives? You got to get on it. Just like Peyton did. All right. So yesterday we stopped here with these inequalities. We are trying to solve the following system of inequalities. So what are we looking for? What are we trying to do in order to solve that system of inequalities?
A boundary line. Well,
You got to start with boundary lines.
you're looking for all the constraints, and then you make the boundary line based off the constraints.
Well, okay, so one thing I want to clarify. These are inequalities that have boundary lines.
Right.
Constraints are more for the real world context, and we make inequalities off of those
Oh
constraints.
yeah, right, never mind.
Okay? But what, like if I'm going to find the solutions to this system, what am I looking for?
Well, you first have to make the boundary line for both, and then wherever it overlaps, or wherever
that. Where what overlaps?
where both the inequality solutions overlap.
So those shaded regions overlap, right? The solutions to both inequalities.
Well, not the shaded regions, the shaded regions where they overlap, because both of
That's
them
what
are
I said.
shaded regions.
That's what I said.
Shaded regions.
Where they overlap.
Yes.
Alright, let's get to work though. Let's not wasting time. Talk with each other, learn together. Push on each other's ideas. Mr. Lipman and I will be coming around talking through things. We're working on numbers 1 and 2 to get started. Then we are moving on to the rest. 1 and 2 on the front of the page.
Okay.
There we go. Don't forget, you can use your orange graphic organizer. I told y'all already.